We're nearing the end of our build-up with the stuff between GCSE and A-level, and I think we need to just pay attention to the circle and some of the properties of the circle. It's not wildly necessary, but just to have some brief recap of circle theorem. You should, if you've just finished a GCSE, be very comfortable with this, but there are a couple of points that we can do. So there's a circle, and we know that if we've got a diameter and we're given a centre spot, then angles in a semicircle are 90 degrees. Okay, so we know that that's a 90-degree right angle if we're given that it's got a centre spot. So that's key. You need to lodge that one in your brain. The reason being is that when we look at perpendicular lines or normals, then what we'll have is some idea that these are going to create a 90-degree right angle. Another one that's kind of quite important is the idea that if we've got a tangent, then the radius creates a 90-degree right angle too. So this is really quite key. So that I'll take for granted that you're comfortable with. If we've got a centre spot, O, which will be denoted with an O, then we've got a 90-degree right angle. We would call this the tangent to the circle. So this is the tangent, and the radius is therefore the normal. The normal, we call this the normal. The normal runs at a perpendicular to the tangent. So M1 multiplied by M2 is going to equal -1 in terms of their gradients. Another thing that's key is the following. If we have a point which I'll call P somewhere out here, and let's get some, we'll have a centre spot here. Let's put a centre spot on there. Here's our centre spot. Then the radius out here, from that point to that point, and that point to that point, we create congruent triangles. I appreciate this is not wildly accurate, but now we can put a line through there, and if we call this point P, and we can call this point here R, and we can call this one Q, with O being the origin, we know that OQ, OR is equal to OQ because they are both a radius to the circle. We know that RP or PR and QR are going to be equal because of our circle theorem. We know that they're true, and we know that OP is common to both. So this creates us now right angle triangles just here, and we may use this for our future knowledge. So thinking that circle theorem is over with is kind of not really the case. We need to just ensure that we're on top of things with that. So these congruent triangles. So for example, if we were told the radius is going to be 3, and we're told the distance PQ is 4, and we wanted to find the distance PO, then basic Pythagoras tells us that that's going to be 5. 3 squared plus 4 squared, square rooted is 5. So that's your main point. One thing we will look at, as we touched on it earlier, is that if we have the equation of a circle, let's just do the following. The equation of a circle, and this comes up in the second half of the first year at A-level. Let's just jiggle that around to look somewhere near remotely key. X squared plus y squared is equal to r squared, where r is the radius. So if we had now x squared plus y squared is equal to 9, then we've got an equation of a circle. This point would be 3. This point right here would be 0, 3. This point would be -3, 0, and this point would be 0, -3. Okay, and what you'd end up seeing is that is the equation of a circle, centre 0, 0. Whilst you don't need to know this, it's kind of good to have that bit of background before you go in. So, take-home message. I didn't want to do an awful lot in here. You need to know the right angles in a semicircle with your circle theorem. You ideally need to know that the normal is the radius to the tangent, which creates a 90-degree right angle. And also, this point P creates congruent triangles as its equidistant. PQ is equal to PR. OP is shared, and the radius are also equal. And then we've just briefly looked at the equation of a circle, centre 0, 0, x squared plus y squared, in this case is 9. And that just basically shows a radius. Okay, so what this has got, it's got a fixed locus just round the outside, and that radius is always going to be 3. And you'll come to doing a bit of this later. You may have looked at simultaneous equations. So there we go, basics of circles.